Hello everyone, welcome back to our channel. Today we'll be discussing solve before constraints and how do we use it. So in previous video we have studied bidirectional constraints, and in that we have seen that the value of A will influence value of B and value of B will also influence value of A, correct? But what will happen here is that as B is 3 down 4 bit variable, okay, it will have value from 0 to 15, right? And the occurrence of B going to 0 will be very less, correct? So occurrence of B will be very less. So this less influence B equal to 0 will influence value of A also. So we can say that A equal to 1 occurrences are less, are very less, and occurrences of A equal to 0 will be much more, correct? So suppose in some cases we require value of A equal to 1 for a large number of times, for a large number of iterations. What will we do? What will we do is we'll set the constraint like solve A before B. Okay, we'll set the constraint like suppose we'll randomize A first. If we'll write solve A before B in this like manner, we'll write a constraint solver solve A before B. So what this will do, this will randomize A first and then it will randomize B based on the value of A, correct? And based on the constraint. So here constraints, suppose if we have written the value of A solve before A before B, correct? So it will randomize A first. First it will check the value of A will be randomized as 0 or 1, correct? If it will randomize A equal to 0, then it will give the value of B any out of 1 to 15, any value out of 1 to 15, and if it will randomize A equal to 1, it will give value of B equal to 0. So what we can see here by using solve A before B, we will see that the occurrences of A will often A equal to 1 will often much more A equal to 1. Okay? So let's see in an example how this is done. So this is without solve before constraint. We have written a constraint A equal to B. The example is similar. B is 4 bit variable, A is 1 bit, correct? And if we'll randomize, it will randomize due to the bidirectional nature. It will randomize B first and then dependent on value of A. Okay, so let's see what the output will be. So here we can see that output of B will be a large number of items. Okay, out of 16, 3, 15, 7. So if B will get to 0, then only A is getting 1. Otherwise, all zeros. What we can see here is the value of A will be less, iteration, less number of times, correct? So suppose if we have written solve A before B, correct? So we have written solve A before B. So what the constraint solver will do, it will randomize A first. Okay, suppose it has randomized for 4 number of times A equal to 0, correct? We'll get any value of B out of 1 to 15, 9, 14, 3, 13. Now in another iteration it will randomize A equal to 1 50% of times. Okay, so it now B will be 0, correct? So we can see that by using solve A before B, the occurrences of A equal to 1 got increased. So that's why it will reduce the bidirectional nature of the constraints. Let's see what the theory says. What solve before constraint will do? Solve before constraint specify the order of constraint solving. If the variables are dependent, due to bidirectional nature of the constraints, value of one variable will influence the value of another variable. Okay. Solve before constraints are used to force the constraint solver to choose the order. in which the constraints are solved, right? We can choose the order in which constraints are solved. We can also write solve B before A. So it will always give the value of B first, then only dependency of A, right? Now what constraint solver will do? Constraint solver will give equal weightage to all the possible values. Correct? That's why if constraint solver is giving all the equal weightage to all the possible values, then that's why the occurrences of A got reduced, right? This is the reason that we had to use solve before. On multiple randomization, solver should assign all possible values. Okay. Now, in some situations, we require A equal to 1 more often. So, by using solve before constraints, it can be done. And that we have seen in an example. So, that was the concept of solve before. I'll again repeat it. So, solve before will do what solve before will do. Solve before will randomize A first. Correct? So that the occurrences of A equal to 1 will improve. Correct? So we can say, in short, solve before will specify the order of constraint solving. Correct? So thanks for watching.